Hi everyone, so today we're looking at factorizing by completing the square. Completing the square is another process that we are going to use to factorize. Now in this description here, it does mention that by completing the square, it's the process of writing a quadratic expression in turning point form. We are going to look at this a little bit later on, but basically if you were to graph these ax squared plus bx plus c expressions, you would get a curve that looks like this. The point where that graph turns back around is the turning point, but we will discuss that later on. Okay, so down here we're looking at the process of completing the square. So what we're really focusing on is the b. So you're going to take this b here, put it over 2 and square it. Now you're going to do that twice. The first time you're going to add that number to your expression, and the second time you're going to subtract that from your expression. And then if you have a c on the end, you're going to plus c if you have one. And then you're going to go through the process of factorizing. Now it's probably easier if I explain all of that with an example. So starting with my first example of x squared plus 4x plus 2, I'm going to write my x squared plus 4x as per normal. Then, once I've written that, I'm going to go ahead and do my b over 2 squared. So my b for this expression is the 4. So I'm going to plus 4 over 2 and square it. And then I'm going to subtract the same 4 over 2 and square it. Now by adding and subtracting it simultaneously, you ensure that your expression remains even. You can't just go ahead randomly adding and subtracting numbers. And then I do have a c on the end here, that plus 2, so I'm going to put a plus 2 on the end. Now these three here form a perfect square. So we looked at factorizing perfect squares last time. Basically you're taking the x, you're putting it in the bracket, and then whatever number is in the middle of this bracket, you're going to put inside your factorized bracket. So I'm going to plus 2. Now, how I know that I need to plus 2 and not minus 2, it comes from this plus here. Whatever sign is in front of that middle term is what sign goes inside your bracket. Then you're going to close the bracket and square. Then we're going to look at the numbers that are outside of our bracket. So 4 over 2 is 2, squared is 4, so I've got minus 4 plus 2, and then so collecting my like terms there, I've got minus 2. Now, if you did want to factorize it fully, this is your turning point form. So you could stop there if you wanted to. If you did want to fully factorize it into a difference of perfect squares, you can go ahead and do so. So to do that, we need to bring this minus 2 inside of our bracket. Now, generally, if we have a difference of 2 squares, we would take the square root of both of these numbers. Obviously, 2 does not have a square root, so it's going to stay as square root 2. So in my first bracket, I'm going to bring my x plus 2, and then I'm going to minus the square root of 2. And then I'm going to do the same thing in this bracket, but plussing the square root of 2. So this x plus 2 stays the same from this bracket, but each of these I'm minusing the square root of 2 and plussing the square root of 2. And coming down to this example here, I've got x squared minus 9x plus 1. It's also important to note with these examples that they are monic, which means that they have a 1 outside of the x squared. If they had a number that was bigger than 1 or less than 1, such as a negative integer, you would have to factor out that number before you could complete the square. So going through the process again, I've got x squared minus 9x, and then I've got my b term, which is the minus 9. So I'm taking 9 and I'm plussing 9 over 2 all squared, subtracting it, and squaring it, and then I've got my plus 1 on the end. Now, these three go in my bracket, so I'm taking my x. Now, this time I have a minus here, which means that there is a minus in my bracket. Now, for my last example, 4 over 2 went perfectly. 4 divided by 2 is 2. Obviously, 9 cannot be perfectly divided by 2. I would get a decimal, so leave it as 9 over 2 squared. And then minus 9 over 2, so 9 over 2 all squared is going to be 9 squared is 81 over 4 plus 1, and then minus 81 over 4 plus 1 is going to give me minus 77 over 4.